Alright, so for this recording, what I will try to do is try to consolidate all the work that I've covered in this channel on analytical geometry, right? From the basics of calculating the gradient, the distance, finding the midpoint, dealing with parallel and perpendicular lines, all that stuff. I'm just putting all these concepts or trying to consolidate all these concepts under one video, which is this video. So I took a question from a grade 12 question paper. I can't remember which year and which term or which examinations this question 3 was written on. But yeah, it's just a question that is adapted from a grade 12 question paper. Okay, so it's it's a two-part question. There's 3.1 and 3.2. Okay, so in this question they say in the diagram below, A, C, B, and D are the vertices of a quadrilateral. Okay, so what did I write? Okay, so for this we are given a quadrilateral A, C, and then it takes us to B, then back to D. So this is the quadrilateral in question, right? So you can see that all the vertices, the coordinates for the vertices are given, all except for one, that is D. So we are given A, B, C, but not D. Okay, so take note of that. And then E is the midpoint, important, is the midpoint of line CD. And the point of intersection of the diagonals A and the point of intersection of the, okay, so this point E is also the point of intersection of the diagonals for which quad for the ABCD quadrilateral. Then we're also told that the AB is perpendicular to CED. CED is this line is perpendicular to AB. And angle theta is the angle of inclination of line CB. I like this question. Reason is the fact that it covers all the concepts that were discussed in this channel. Okay, so finding the equation, working with gradients, working with midpoints, perpendicular lines, parallel lines. So it encompasses most of the stuff I've discussed in this channel. So check the description box as well. You're gonna find links to other recordings that I've created for analytical geometry. Okay, so 3.1, let's answer the first question. 3.1.1, they want us to calculate the gradient of AB. Let us check something. In order to calculate the gradient, how many points do you need? You need 2 points in order to calculate the gradient. So let's do that. Let's calculate the gradient AB. I have 2 points. I have B as well as A. So gradient AB is gonna be YB minus YA over XB minus XA. What is YB? YB is gonna be 1. It's 1 as you can see there. Minus YA it's 5 over XB. XB that's 4 minus XA it's negative 4. So the difference on the numerator gives us a minus 4 over 4 minus negative 4, that gives us an 8. So the answer is a negative 1 over 2. Let's check. Negative 4 over 8 gives us a negative half. Check. Alright, now 3.1.2, they want us to calculate what here? They want us to calculate the equation of the line AB, the same line where we calculated the gradient for, right? So when you want to find the equation for a line, equation of a line, as I've explained, you can either use the y equal to mx plus c, or you can just use this one, y minus y1 equal to m in bracket it's x minus x1. You can use either of the two equations, but both of these equations they demand us to have a one coordinate, no, not one one point, and the gradient of the line. So far we do have the gradient for the line AB, yes, which is m equal to a negative half. It was calculated above, right? It was calculated above. So now we can calculate the equation for the line using either point A or point B. It doesn't matter which point you pick. So I'm going to take point A, which is minus 4 and 5. Let's work out the equation for the line. I'm going to use this equation. So the y minus y1 equal to gradient multiplying x minus x1. So it's going to be y. What is y1? It's the y coordinate for the chosen point. It's 5. We substitute. What is the gradient? It's a negative half x minus, what is x1? It's the negative 4, the x coordinate for the chosen point. So it's y minus 5 equal to a negative half x. Here it's going to be a plus 4. Then it's y minus 5 equal to a negative half times an x. It's a negative half x. Negative half times 4, that's negative 2. Transpose the 5. Y is now equal to a negative half x minus 2 plus 5. The equation now becomes plus 3. Negative half x plus 3, right? Of course, if you use the mx plus c, you're still going to get the same equation I have calculated. Now for 3.1.3, they also want us to calculate what? The equation for CD. I think I'm going to need more space for this. Okay, I did not erase, I just hidden the calculations, but just try to make a mental note of the calculations we have done so far. But we're going to go back to them in case we need some more information in order to calculate. Okay, so 3.1.3, let's get the equation for CD. Let me show you where CD, or let me just highlight the CD line. It's this line. They want us to get the equation for this line. Okay, again. If you want to find the equation to or for a straight line, you need a gradient for that line as well as any point along that line. Okay, let's see what we have. I have only one point along the CD line, right? So I cannot calculate the gradient for this line directly. Yes? Pay attention. I'm saying we cannot calculate the gradient for this CD line directly. However, there is a special relationship that exists between the CD line and the AB line. The AB line, which is this line, now by that small square here, we can see that these lines are perpendicular. So there's a special relationship between these two lines, which is the fact that they are perpendicular to each other. We know from theory that perpendicular lines, when you multiply their gradients, you should get a minus 1. So we're going to use that property to calculate the gradient for the line CD. So gradient CD multiplied by gradient AB is equal to a minus 1. I'm using this property because I don't have two coordinates to help us calculate the gradient for CD. So gradient CD will be calculated using this equation or property. So we calculated on the previous question oh, the first question, that gradient AB is what? It's a negative a half equal to -1. So we're just gonna manipulate this and make MCD, the gradient of CD, the subject of the formula. So I'm gonna divide both sides by a -1/2, even this side a -1/2. So the gradient for CD, this and this gives us a 1, -1 over a negative half gives us a 2, a positive 2. Ding, ding, ding. I now have a gradient. I also have a point. Therefore, I can calculate the equation for the straight line. So y minus y1 equal to gradient multiplied by x minus x1. Okay, I'm again using this formula. So for y1 and x1, I'm going to substitute the coordinates for the chosen point. In this case, we only have one option, it's that C point. So y minus, what is y1? That is the -4, equal to, what is the gradient? We calculated it, it's 2, open bracket, x minus, what is x1? It's the -1 in that C coordinate. So y is going to be a +4, 2, then it's going to be an x plus a 1. Then we simplify, it's going to be a 2x plus 2. Then y is equal to 2x plus 2 minus 4. Minus 4. So what I've done is I transpose the 4 over to the right hand side. So on the right hand side, we have the 2x plus 2, 2x plus 2 minus 4. No funny business. So 2x, 2 minus 4, that's a -2. This is our answer. This is the equation for line CD. Line CD. Okay. Now, next question, 3.1.4. They want us to calculate the coordinates for E. What are the coordinates for E? So that coordinate E, that point E, is also another special point. We call this point the point of intersection, right? It is the point of intersection. So let me just hide this and say, okay, I know that the equation for line CD was calculated to be a positive 2x and -2. Just to double check, yes, I got that one correct. And then the line AB, I'm also gonna need that. It's what? It's y equal to -1/2 x plus 3. Let's hide this. Okay, now I have the equations for these two lines, CD and AB. The coordinates for E, since the point E is the point of intersection. So how do we calculate coordinates for a point of intersection? We solve the equations for the two lines, creating that point of intersection simultaneously. So I'm gonna say for 3.1.4, the first equation is gonna be the 2x minus 2, equation number 1. Second equation is that y minus 1 over 2x plus 3, equation number 2. Okay, equation number 2. So in order to get the coordinates for E, I have to solve these two equations simultaneously. So I'm just going to equate them, or you can just use the elimination method by saying equation 1 minus equation 2. Since the coefficients are the same for the y, so I'm going to eliminate the y through the elimination method. I'm subtracting equation 1 and 2. So y minus 1, that's 0. 2x minus a half, that gives us a positive half. So 2 minus a negative half. That's a 5 over 2x. And then a minus 2 subtract 3. That's going to be a -5. Not -3, but a -5. Then we're going to calculate x. So it's -5 over 2x is equal to -5. Then we're going to do a multiplication on both sides of the equation by the multiplicative inverse of the coefficient of x. So it's a 2 over minus 5. Or we can just divide by the negative 5 over 2. This cancels this cancels that. X now becomes, this cancels this, the 2 is the value for x. Okay, so we are not done. We have the x coordinate. Now let's calculate the y coordinate. So I'm going to use the first equation to calculate the y. So y now becomes a 2. In bracket, it's going to be the x minus 2. Then y is 4 minus 2. Then y is equal to 2. So the coordinates for E are 2 and 2. Okay. So this is how we get the coordinates for E. Now 3.1.5, they want us to get the equation of the line parallel to BC. I'm gonna hide this. Now let's address this question. But first, we need to understand what is really required of us here. Okay, so 3.1.4, 3.1.5, the equation of the line parallel to BC. Where's BC? BC. Okay, here's BC. Here's BC. So they are saying there's a line that is parallel to BC and it passes through A. So there's also another line that passes through A, like this. Okay, so they want us to get the equation of this line that is parallel to line BC and it passes through A. So this line BC is parallel to some line which passes through point A. They want us to get the equation for this line. Okay, again. Let me repeat this. They want us to get an equation of a line. So in order to get an equation for any line, you need two things: gradient and one point. By 1 point I mean a point with an x value and a y value. Okay, so guess what? I do have a point, check, for this line. However, I do not have the gradient. So I have a bit of a problem here, right? Because in order to calculate the gradient, I need 2 points. I don't have those 2 points. I only have one, which is the point A. However, the gradient can be calculated through the property of parallel lines. So parallel lines have equal gradients, right? So the gradient here is going to be equal to, it's going to be the same as the gradient on line BC. So we have to calculate this gradient first. So gradient BC, it's YC minus YB over XC minus XB. So what is YC? YC, it's a negative 4 minus what is XB? It's a 4 divided by what is X? What did I say? YC, it's negative 4. YB, it should be 1, not 4. It should be 1. And then XC, that's a negative 1 minus XB, that's a 4. Then it's a minus 5 on the numerator. Denominator, it's also a minus 5. So the answer is going to be what? A positive 1. So it means that for the line that passes through A, the gradient is also equal to 1. Parallel lines have equal gradients. I had to calculate the gradient for BC in order to get the gradient for this line. So they are equal because they are parallel lines. So I now have the gradient for the line and a point. I'm going to use the y minus y1 equal to m x minus x1. So it's y minus y1. Y1, I can either, no, I have only one option. It's the point A. So the y1, the y coordinate for the point, it's going to be a 5 equal to gradient, it's 1, x minus what is the x coordinate, it's a negative 4, close bracket, y minus 5 is equal to 1, x plus 4, we remove the bracket. I now have a x plus 4, and y is equal to x plus 4 plus 5. So that's a 9. Y is equal to x plus 9. So this is the equation of the line that is parallel and passes through A and parallel to line BC. Okay, let's wrap it up with 3.2. So 3.2, another special case question where it talks about the value of theta. This value of theta. What do we call this angle? What do we call this angle? Unfortunately, you are not here to answer this question. It's the angle of inclination. It's what we refer to as the angle of inclination. So that is what we are going to calculate. So angle of inclination is calculated as what? Gradient equal to tan theta. So the theta is the angle of inclination. M is the gradient. So this angle of inclination is, however, created by the line A and BC, right? In order to get the angle of inclination, I need the gradient for line BC. It's 1. Then tan theta, the theta is now going to be equal to the arc of tan 1. Then theta is equal to a 45 degrees. After punching your calculator, you can see that the answer should be a 45 degrees. So this is our answer for 3.2 and the final question for this discussion. Okay, you have any questions? Let's talk in the comment section. Right, you enjoy the content, leave a brother a like, man. Nah, just leave a brother a like. Okay, so I'll see you on the next one. I hope you enjoyed the recording, the lesson. For now, I'm signing out. Peace.